Welcome to the webinar. We're going to have a look at increased manufacturing, quality and throughput. My name is Gideon Besaidnat and I am an application engineer for micrographics. Now, what is on the agenda for today? Going to have a look at the introduction, the importance of quality and throughput in manufacturing, ensuring product quality in Autodesk Inventor, key features to ensure product quality with Inventor, improving throughput with Inventor, ensuring product quality in Autodesk Fusion, the key features to ensure product quality within Autodesk Fusion, improving throughput with Fusion, and then we're going to have a closing summary. Now, in today's fast-paced and highly competitive manufacturing landscape or modern engineering industry, we do get specific tools that assist us in transforming the way we think and teams work. These advanced solutions enables the organizations to streamline their workflows or even boost productivity. You can get consistency and deliver exceptional products. By harnessing cutting-edge digital design and validation capabilities, companies can unlock new levels of efficiency and innovation. Now, some of the things we're going to have a look at is the streamlined workflow, enhanced product quality, optimized machine performance, efficient data reuse, the overall impact. Now, if we look at enhanced product quality, this is done through standardizing the processes or the best practices within any company. We can also have a look at the built-in simulation tools and tolerance analysis. Now, this all ensures that you do have reliable and high performance components within quality specifications through production. We all know how important quality checks are within every company. Optimized machine performances and process performances. This is by validating basically the mechanical systems with motion studies or your fit and interference checks and performance simulations. And this can reduce cost. It can also reduce costly mistakes. Can have a look at unplanned downtime and production bottlenecks because everything does get checked in the beginning stage. When it comes to efficient data reuse, and we think about efficient and faster engineering cycles using configurable design templates, modular components, or intellectual duplication tools that enables teams to repurpose proven designs. You can save so much time by data reusing. Together, these capabilities directly support the increase of throughput, reduction of rework or reduced rework, and reduction of scrap. We can make smarter choices by making the manufacturing life cycle driven and continuous improvement. Operational excellence and sustainable competitive is always an advantage. You can get your quotes out quicker into production, start your production, and you'll be able to track and see how everything in the production line fits. Now, we all know how important quality and throughput is in the manufacturing industry. Embedding quality into the design process helps to reduce errors, improve consistencies, and validate components before production. It's a very key point when it comes to quality in any company. We're going to have a look at the importance of quality and throughput in manufacturing. Now, in the modern manufacturing, quality doesn't start at the end. It always starts at the very beginning in the designing phase. By leveraging advantages or advanced digital engineering tools and looking at the standardized processes or workflows within teams or within your company, you can build quality into every step of the development process. These tools also helps to catch errors early, improve design consistency, and validate components long before they hit the shop floor. The results: less rework, shorter production cycles, and higher throughput across actions. And here we can see quite a nice graph of the maintaining of profitability, your customer demands, high value products, and critical performance indicators like KPIs when it comes to the shop floor or the products and so on. Now, a very important thing to remember is that quality and throughput are two most critical performance indicators. Striking the right balance between them is essential for delivering high value products, meeting your customer demands, and maintaining profitability. Now, what is the key features that support quality and throughput in manufacturing? First, we do have the standardized design practices within any drawing office. You can set up a standard that everyone has to follow and work according to, and this really does help and support the quality of the work that's being put out. Built-in validation and simulation tools within the design, you'll be able to see if your 3D models or your assemblies or so on actually do fit, because you do have the validation, you do have the simulation where you can look at, for instance, stress analysis, and then, like I mentioned, your tolerance and fit analysis where you can check, for instance, if your parts fit in your assembly or if there's any interference. Automated error checking, and all these tools does help and assist with the support of quality and throughput, especially when we think about automated error checking. Data reuse and configuration tools. We all know how important it is to be able to reuse some existing data. It saves so much time that you don't have to go and remodel, for instance, something from a previous project, and you can reuse that data into your current project. Then you've got your digital prototyping. When we think about Autodesk Inventor or Autodesk Fusion, you actually do see your 3D model, and you'll be able to see your assembly, and with all these key tools, for instance, tolerance, you'll be able to see your limits, your fits. Are there any interference within your model or assembly? And then workflow automation. And lastly is the integrated documentation and the collaboration of version control. Within your integrated documentation, that might be your company templates for your 2D drawings, collaboration if you work across your teams, and we all know how important version control is. And all of this will lead to production, ready models, and data. What is standardizing design practices? And what is the key factors? It enforces consistent modeling methods, reduce variation between your engineers, ensures every product meets defined quality requirements. And one thing I always talk about, it is the three-step system. Plan what you're going to do, look at the quality of what you're doing, and then streamline it. Built-in validation and simulation tools. It assists in detects design flaws quite early. You can perform your stress, motion, and performance check. It minimizes defects before production begins. And we all know this is the key goals for built-in validation and simulation tools. And more built-in validation simulation tools like tolerance analysis ensures components and assemblies are correct. It reduces the scrap, rework, and misalignment issues. Because if we think about the designing process, you might have, for instance, on the bush, you might have a maximum tolerance and a minimum tolerance, and the shaft, you do have a minimum and maximum tolerance, and that is where limits and fits comes in, because you might be able to machine the bush, let's say, a little bit bigger because it's intolerant, and if you machine the shaft to the minimum spec, you're going to have fit issues because of your limit and fit tolerances. And all of that can improve reliability of your final product. Automated error checking. It identifies missing dimensions, interference, and inconsistencies within your 2D environment of a 2D sketch. If you think about the constraints, either in Autodesk Inventor or Autodesk Fusion, it means you're eliminating the degrees of freedom, the degrees of movement of that sketch, and that can actually help quite a lot when you go into the 3D environment to create your model. It helps to eliminate manual oversight, a very important process. And all of that will lead up to approval workflows, and it really does speed up the workflows. When we look at data reuse or configuration tools, we are looking for faster development, error reduction, improved collaboration between your teams, and greater consistency. And this starts at standard components and templates. Quickly adapt existing designs for new use. Reduce cycles, times, and it does boost throughput within manufacturing industry. Digital prototyping. You can test your ideas virtually before physical manufacturing. If we think about, for instance, a multi-body design within Autodesk Inventor or Fusion or your 3D software, it really does show you your physical part within the 3D workspace. So if you need to make any changes, you'll be able to do so. And I know a lot of companies do use multi-body as a test demo, especially when it comes to new design ideas. So you can then test that idea. Once the idea has been completed, you can then go and start your modeling process. And that does create faster iteration and decision making. And one of the key benefits is it does reduce cost and time spent on physical samples. So you don't have to go and create your physical assembly. You don't have to manufacture, because that's also going to push up your price of the production. Workflow automation. This automates your repetitive tasks. for instance, naming, numbering, and documentation. It frees up engineers for higher value work, so they're spending less time in the office looking at the designs or creating your models or drawings, because it does free them up for the higher value work where they can be in the production floor or even go into the higher value work meetings to be able to discuss the different workflows and so on. And all of this leads to improving the throughput and the overall productivity. Integrated documentation. Automatically generate drawings, BOMs, and specs. And within Autodesk Inventor, this is where the screenshot comes from, where you can take that bill of materials and actually export it to Excel that you'll be able to go and utilize within the company. This ensures the accuracy and traceability of your parts, your components, your BOM structure and quantity, and so on. It reduces the delays in production handover. Collaboration and version control. And a very good example of this would be, for instance, just the homepage on Autodesk Fusion, where you do have your model, and you'll notice I've got a version 2 of that specific assembly, and you'll be able to see the history, the uses, where it was used, and drawings. And if you think about version control, for instance, and look at Vault Basic, Autodesk Vault Basic, that works hand in hand with AutoCAD and Inventor, you'll be able to look at your version control, and you'll have also your history, where it was used. You'll be even able to see the 3D model within Autodesk Vault. And all of this leads to ensuring that teams work on the correct file version. It prevents error caused by outdated or duplicated designs. It supports your smooth engineering to production communication. Now let's talk about why built-in validation and simulation tools are game changers in the manufacturing or design industry. So instead of waiting until physical prototypes for your quality department to find these issues, these tools lets us simulate real-world forces, motion, performance conditions, and even tolerance checks. That means that engineers can spot potential problems before production even starts. What does that give us? Optimized components, verified assembly behaviors, and confidence that everything works together as intended. And here's the big win. Catching flaws early keeps quality high, reduces unnecessary rework or scrap or even iterations. It prevents costly rework or products going to the customer for the products not to be accurate or fit in the assembly once the customers start with the assembly process. All of this shortens the entire development cycle, creating a predictable, streamlined path from concept to production. The bottom line is these tools help manufacturers or engineering industries to deliver reliable, high performance, high quality products faster and more cost effective. When we think about the design smarter, deliver faster, it all comes down to product quality. How efficient is your designs? How did you improve your manufacturing throughput? Are your customers happy? And final thoughts, how can we streamline this moving forward? Now, one of the key points when it comes to quality within the manufacturing industry, it would be ensuring product quality within Autodesk Inventor. Now, Inventor involves leveraging its integrated tools and workflows to embedded quality throughput. The design process, rather than rely only on inspection quality or your inspection quality checks, to the degree to which a product or process meets defined requirements and expectations. Inventor really helps the teams to embed quality directly into the design process. And you do have all the different providing tools that reduce errors and improve consistency. You can validate your designs before they reach the shop floor. So quality is defined, proactive quality approach, integrated tools and workflows, validation before production. Quality defined is the degree to which a product or process meets defined requirements and expectations. The proactive quality approach is to remember that quality starts in the beginning stage, not at the end stage, not just at final inspection, but in the beginning at the design stage. Autodesk Inventor supports quality. When we think about your integrated tools and workflows, embedded quality throughput to the design process, you've got your error reduction where you can detect and prevent design flaws early. Consistency, where you can enforce a standardized design process. Validation before production, where you can simulate and verify designs before they reach the shop floor. What is the key benefits? You've got fewer errors and fewer rework. You've got an improved design reliability and manufacturing process, and streamlined path from beginning concept to the end, the production and final process of your model. The key features to ensure product quality within Autodesk Inventor, it is tolerance analysis. If you do have the PDM, Production Management Collection, or Production Manufacturing Collection within Autodesk, you do get Inventor Tolerance Analysis, you get Inventor Nastran, so you do get this built-in ideas that can help you to streamline your workflow and improve the quality and ensure throughput within one key software. So you do have your tolerance analysis, your simulation and stress analysis. There we can see it's quite a nice picture of a stress analysis going to be done within Autodesk Inventor. But if you do have the PDM collection, you can even go further with Inventor Nastran. And then your interference checks. So you do have your default interference analysis that you can check within Autodesk Inventor. Tolerance analysis is a critical part of the design validation process in manufacturing. It ensures that even with manufacturing variations, parts will fit and function properly in an assembly. Now, Inventor does simplify and enhance this process through powerful built-in and integration tools. Why tolerance analysis matters. We can check for assembly failures, poor product performance, for instance, interference checks, poor product performance, increased scrap and rework, customer dissatisfaction. And this is what it all can lead to if you do not go and look at your 3D models and your tolerance analysis. Manufacturing processes are never perfect. Variations in material, tooling, and assemblies lead to small dimensional differences. If not accounted for, these variations can result in all of these, like assembly failures, your poor product performance, increased scrap and rework, and customer dissatisfaction. Tolerance analysis helps mitigate these risks by evaluating how various accumulative tools or components across multiple components will fit or work together. The benefits of performing these tolerance analysis within Inventor: you've got your improved quality. This will ensure that your parts fit together or correctly the first time. Reduced cost, where you can minimize over tolerancing that can increase machining or even inspection costs. Faster prototyping, you can catch your design issues early without relying on physical prototypes. Better communication, clearly communicate tolerance intent to manufacturing teams using 3D annotations or drawings. And the key takeaway from this is tolerance analysis in Autodesk Inventor allows engineers to design with confidence and ensure that parts are not only met by the specification individually, but also perform a reliable part of a complete assembly to reduce the risk, waste, and cost throughout the product lifecycle. Another tool we're going to have a look at is simulation and stress analysis in Autodesk Inventor. Now, simulation and stress analysis is quite an essential tool in the engineering design process. This enables your teams to test and validate products virtually before committing to physical prototypes. Autodesk Inventor includes powerful simulation features that allow users to assess product performance under real-world conditions directly within the design environment. What is the key capabilities in Inventor? Stress analysis environment, where you can perform static stress analysis, apply forces, pressure, and constraints within your loads to see how the model would be formed. You can visualize results such as stress distribution, strain, or even your displacement. You can also look at the safety factor that is required. Frame and beam analysis. This is ideal for instance structural frames that is made from standard profiles. You can calculate, for instance, bending moments, your shear force, and deflections in a lightweight solver. Model analysis or dynamic behavior, where you can determine natural frequencies of a component, identifying potential vibrations, issues early in the design. Contact and assembly analysis, we can simulate how much parts interact under load, define context sets to evaluate realistic movement and stresses. There you can also see is quite a nice study of a simulation that you can form within Autodesk Inventor. Now, why do we use simulation in Inventor? It reduces prototyping costs, it shortens development time, improve product quality, and optimize material usage. If we think about a typical application, You can validate a bracket strength under applied load, test housing deformation for electronic enclosures, analyze gear or shaft deflection, evaluate frame structures of buildings or machinery. And the key takeaway is that Autodesk Inventor's simulation and stress analysis tools empowers engineers to design smarter by making performance-driven decisions before fabrication begins or before production begins. And it makes it a lot safer and more efficient. And one of the biggest things, it is cost effective. Interference checks within Inventor is quite a vital step in verifying that parts in an assembly actually fits together correctly without overlapping in physical space. Autodesk Inventor does provide built-in tools to automatically detect these issues, helping engineers prevent assembly errors and costly rework. Now, what is an interference check? An interference check analyzes two or more components within an assembly to see if their volumes intersect. So here we do have quite a nice image where we can see this pin actually does intersect. So this can then quickly go back to the engineers. They can have a look at the dimensions and make the modifications even before production starts. Now, what is the key features in Inventor? Automatic interference detection, where you quickly just go and scan the entire assembly or even select your different components, and it would actually just highlight the areas where the parts intersect, and it would display the volume interference of the affected bodies. Live feedback during the assemblies. While inserting or constraining parts, Inventor provides real-time visual cues if components clash. It prevents your errors before constraints are finalized. An interference report generates a summary report that details the volume of interference, and you can print it or even save it and then share it for design reviews. Integration with design review. You can use Autodesk Vault and share design views to collaborate across your teams, flagging the issues quite early in the process. Why it matters. It avoids assembly errors. It saves time and cost. Improve your communication. Increase product reliability. Now, a typical use case would be, for instance, checking for fit between a fastener and a hole. You can validate your clearance in the gear assembly, ensure electronic components don't collide with housing, review packaging or enclosed design. The key takeaway is that with Autodesk Inventor's interference check tools, engineers or even designers can catch critical design issues early. You can then communicate with the engineer and make the modification before you even start production. And this will save time, reduce waste, and ensure a reliable assembly, and you can save so much cost. Improving throughput with Autodesk Inventor. Throughput depends on design works that are efficient, repeatable, and scalable. Autodesk Inventor empowers teams to develop products faster while preserving accuracy and design integrity. The goal is to speed up design creation and reduce repetitive work. The focus: efficiency, automation, and flexibility in the design process. The key features that improve throughput would be iParts or iAssemblies, where you can quickly generate multiple design variations across product families, enable rapid customization without rebuilding the model. For instance, if we think about iParts, you do have a single part that you can have different variations. Those variations you can take into what we would call an iAssembly. So you do have your different assembly variations. Quite a new thing that was brought in with Inventor 2022 is model states. With model states, you can generate different states of your model. For a very good example I like to use is, for instance, different machining variations of your model or different machining stages of your model. And all of this actually does get saved within a single file. So for instance, let's say you do have a coupling that you are manufacturing. You can create your model states and have your first machining stage or your, for instance, forging or casting state. From there, you can have a machining state. You can have a step 1 machining state if you need to go back, for instance, heat treatment. When it comes back from heat treatment, you can have a final machining state. So you can go set up all that different model states. The same within the assembly environment. You can have different states of your assembly. A very important tool would be design reuse tools. That helps you to reuse your existing components through either derived parts and the design assistant, or minimize repetitive work and speeding up development. iLogic automation, where you can automate routine tasks and create configurable models in a second, eliminating manual steps and ensuring consistent outputs. Your parametric and direct modeling make fast, precise design changes while maintaining the model integrity and reducing time spent on rework. Any CAD interoperability, so you can work with data from other CAD systems without translation and ensure smooth collaboration and reduce delays. Improve drawing automation, generate production-ready drawings faster with templates, automated annotations, and standardized documentation tools. Improving throughput is looking at, for instance, iParts, iAssemblies, your design reuse tools, parametric and direct modeling, digital interoperability, your improved drawing automation and integrated automation processes. Ensuring product quality would be, for instance, tolerance and fit analysis, built-in simulation tools, automated error checking, integrated documentation, collaboration and version control, as it's quite important. Ensuring product quality within Autodesk Fusion. Quality defined. It's the degree of which a product or process meets defined requirements or expectations. You do have the proactive quality approach, where quality starts at the design stage, not just at the final inspection. Now, how does Autodesk Fusion support quality? You've got your integrated tools and workflows that's embedded quality throughout the design and manufacturing process in a single platform. Error reduction, where you can detect and prevent design flaws early in the system. You've got your consistency that enforces a standardized practice. Your validation before production, you can simulate stress, motion and performance, and if you do have some like the manufacturing extension or the the simulation extension, you can go and look at even further built-in simulations or manufacturing processes. And the key benefits is still fewer errors in rework, improved design reliability and manufacturing, and a streamlined path from concept to production. And within Autodesk Fusion, you've got your built-in simulation, tolerance and fit analysis, digital prototyping, automated error checking, your integrated documentation, and your automation of version control. So every time when you save a model, you do get a new version, and this also allows you to roll back to a previous version. Now, integrated simulation tools, for instance, if you do have the simulation extension, because this is required to get the full simulation package that is available within Autodesk Fusion. It includes stress, thermal, model, and generative simulations, detects weakness early in the design, optimizes performance before physical prototyping. And here you can see all the types of studies that you can go and create if you do have the simulation extension. From static to thermal to structural buckling, dynamic event simulation, shape optimization, and even injection molding simulation. A key aspect would be parametric and history-based modeling. Because you do have your full history of your model, you can identify clashes, misalignments, and clearance issues automatically. Validate assemblies for correct fit and production, and reduce costly errors to ensure a reliable operation. Your automated interference and fit checking. Here we do have quite a nice example within Autodesk Fusion where we did do a small interference check and compute the analysis so that you can see there you've got your volume of the interference, and all of this will identify the clashes or misalignments and clearance issues automatically. It validates assemblies for correct fit before production, reduce costly errors, and ensure a reliable operation. Your tolerance and GD&T tools that supports precise dimensioning. Now, if you do have the full manufacturing extension, you also do have access to more inspection tabs that you can go and do a full precise dimensioning of your model within Fusion. It ensures your manufacturing within specs and minimizing rework and scrap. And yes, this is an inspection tool where you can go and see your tool paths to be able to get your different inspection and dimensioning as needed. And all of this can be done before manufacturing. A key factor is within Autodesk Fusion, for me, it's definitely automated documentation generation. It creates accurate drawings, your BOMs on or parts list, and specs automatically onto your 2D drawing sheet. And this will reduce human error during handoff and keep stakeholders aligned with up-to-date info. So here you can see it's quite a nice example of an automated 2D drawing being generated from a 2D part, where you do have all your different types of options of what you would like to generate, from baseline dimensions to ordinate dimensions and symmetric with ordinate dimensions. And if you're not happy with these ideas, you can just simply click at the bottom and you'll be able to find more ideas or variations of your model. And this is just with a single one. Autodesk Fusion does have the capability to run a full or create or automate a 2D data sheet of all your drawings in an assembly. For instance, if you have 10 parts, you can create 8 sheets. The first one would be an automated parts list with automated balloons of your assembly, and then each one after you can go and see each part individually. It does still have subhuman interaction needed, but you save so much time. Another key aspect is built-in CAM verification within Autodesk Fusion. This simulates machining paths to detect tool collision. It verifies manufacturing feasibility within the design environment, and it aligns production quality with design intent. Quite unique within Autodesk Fusion. And 2 and 3 axis machining capability does come out with the standard Fusion. If you want 4 or 5 axis or even simultaneous axis machining, you can get the manufacturing extension and be able to go and create those tool paths and code as needed for your machining. Now, what is the key features that improve throughput of Autodesk Fusion? The goal is actually to enable faster completion of design to manufacturing workflows by minimizing time to result, whether that's from opening files to generating drawings, optimizing toolpaths, or managing your shop floor execution. And here we can see the key features. So you've got your unified CAD/CAM environment. It does work seamlessly across design and simulation. You do have real-time collaboration and cloud data, where you can collaborate instantly with team members. Another function of Autodesk Fusion is you do get the Autodesk Fusion app that you can download on your mobile device from Google Play Store. You do need to have an active Fusion license. So once you download the Fusion onto your cell phone, you just sign into your Autodesk account. So if you are in production, you'll be able to see your 3D models that you have created, and there's a few tools available like the measuring and so on. And this also really does help with real-time collaboration. You do have your automated CAM and toolpath generations, where you can explore multiple optimized designs. If you do have the functionality, you can go and look at generative design, where you can explore multiple optimized design alternatives of your current model, where you can save material and cost. So all of this leads to generative design for rapid iteration, your integrated simulation, and connected manufacturing workflows. Autodesk Fusion, when we think about driving innovation and quality throughput, you do have a uniform platform. This connects global designs and manufacturing teams in one environment. You've got your integrated tools that combines advanced design, simulation, and validation concepts and capabilities. Quality at every stage. And this ensures product reliability from the beginning to the end. So from concept to production, end of production. Real-time collaboration enables teams to work together seamlessly across different locations. Across our accurate digital testing, simulates real-world conditions to identify issues early. This streamlines the workflows that reduces complexity and accelerates development cycles. Empowering innovation. This helps engineers to solve tomorrow's challenges today. Consistent, efficient delivery that produces high performance products faster and more cost effective, and very important, quality products. Improving throughput within Fusion and Inventor. Fusion is cloud-based, and you do have your cloud-based collaboration, your integrated CAD, CAM, and CAE systems, rapid iteration. Autodesk Inventor, advanced parametric modeling, high precision and control checks, robust simulation tools, and enterprise level integration that fits into large scale workflows when we think about Autodesk Vault as an example. And to close off this webinar, just to highlight the key points why it's quite important, because you do have your enhanced manufacturing quality, optimized machine and product performance, automation of reuse. You can standardize your workflows, and all of this will lead to fewer errors and lower cost, and you can save so much time within the product suite. And with all these different types of softwares, you can integrate quite nicely within all the products from Autodesk. And there's quite a lot more that I could have gone through, but I did focus on Autodesk Inventor and Autodesk Fusion. Thank you guys for watching. Please like and subscribe and follow for more content. You can visit our website at www.mgfx.co.za. You can email us at info@mgfx.co.za. Please like and subscribe and follow for more content.